let's be real. Two very successful videos to start off. Son of the teacher of the universe, doing big things. I mean, we had Disney and Lego Day. It's pretty solid to start off with. Yesterday, Wrestling Day. I mean, Ric Flair showed up. Woo! How can I top that? How can the son of the teacher of the universe top that? I got it. It's a baseball day. It's Friday. It's Friday, April the 3rd. I know the days are getting all kinds of confusing. I'm in the same boat. Thank goodness we're 1 week down of online learning. We can keep this going. What we gotta do first? Oh, of course, we gotta start with Disney pins because that's what I do. So today we're rocking with the Yetis, because I mean Everest, what a great ride. Little bowling pin with Hades on it. What a cool villain. Or actually a hot villain. Kill me. And the Mad Hatter's car. Just some fun ones for a Friday. Got Disney pins. Oh, we gotta open some stuff. Great. I found, because it's a baseball day, the Squeezy Mates. You can end up with any one of these wonderful, awesome keychains. I can get Austin Meadows. There's Rays, let's go. You get Acuna, who's a brave guy. Look, as long as I don't get an Astro player, that's all I really care about, because I will throw it away because they're cheaters. Oh, we're safe. It's just Max Kepler of the Twins. We're totally good. You can hang out up here. We're good. Also, again, because it's baseball, how can you not do baseball cards on a baseball day? Let's see what we got here. Yeah. Paul Goldschmidt, let's go. Byron Buxton, Carlos Santana. Not bad, not bad. Oh, there we go. Give me some Travis d'Arnaud. Rays and Braves love all at once. Love that. And Trevor Story. I mean, it's a pretty good pack of baseball cards right there. Baseball cards, Disney pins. Something I'm forgetting something. Of course, we have to have a demotivational quote of the day. Our throwback, this is from March 27th, from 1 week ago. Deja vu. The feeling you've heard all this crap before. It's a good one. And today's wonderful, wonderful quote of the day. It's not so much for you. This is for your parents. You can bring them in for this one. My kid is turning out just like me. Well played, Karma. Well played. Put our quote up amongst the wall of stuff. Disney pins, baseball cards. Quote of the day. Also, Aiden, great job on winning. What you're going to win, I mean, I can't really give you anything at the moment because, well, I can't leave the house, the whole stay-at-home order. But Aiden was the first one to pick up on what was the mistake from video number 1, so good job, way to go, high five. And now let's get on to the math. Okay, DJ Kitty, pay attention. This is going to be on the quiz.
Got it.
Let's go. Time for a little quadratic function time. We're really at factored form. We remember factoring functions from back a little while ago using our wonderful tic-tac-toe method, of course. Remember that? We'll have a video reviewing that a little bit later on. Spoiler alert. So, we're going to graph this function. F of x equals x plus 1 times x minus 3. Now, we could multiply this out using our super distributive property, of course, or using the FOIL method. And we'll look at that again a little bit at the end. But we're going to actually just graph it based off of this information here. See, I know, because of the way this is written, that there are two values of x that would make this function equal 0. They are our zeros of the function. They're the values of x that would make the function equal 0, which would end up on our graph being our x-intercept. So I know if x plus 1 has to equal 0, what would x have to equal? That's right, -1. You see, y'all so smart. So -1 is going to be an x-intercept. What other value of x would make this function equal 0?
We don't know. Please tell us.
Come on, y'all know this. Y'all are better than that. Think about it. X minus 3. What value for x would make that equal 0? 3, of course. Now that gives me 2 points that are on the graph. If we can find our vertex, we could graph the function from there. And finding our vertex is actually really simple. Since I know the 2 zeros of the function, we can find the x value of our vertex, or our axis of symmetry. We don't want any. Those telemarketers can go away. Ha ha! The axis of symmetry is going to be at x equals -1 plus 3 divided by 2. What's -1 plus 3? It's 2. 2 divided by 2? 1. So the axis of symmetry for my graph be along that vertical line. Which means my vertex is going to be at 1 something. How do we find that something? Just like we did yesterday. Plug in 1 into our equation, we solve. I replace x with 1. 1 plus 1 is 2. 1 minus 3 is, that's right, -2. Multiply those together, we get -4. So 1, -4 is my vertex. Which means, as all you know, my drawing skills are so good, we're going to adjust that just a little bit so it looks a little bit more accurate. We're able to come up with a parabola. Now, is it a beautiful parabola? No, but don't make fun of me. You know I can't draw very well. But we're able to graph this function. All right, so the next thing we're going to look at is another type of factored quadratic graph, quadratic function, in just a second. All right, so just shout out again to the family coming through. Somebody asked, why is Elmo in the picture? The picture's not about Elmo. It's about the blondie sitting in Elmo's lap. That's Brother Ross. Hey, brother. Along with, of course, Anthony, Nelson, Rebecca. Thank y'all for traveling so far, in spite of all of the problems we're having with travel, to come watch a little algebra lesson. And we're back. Graphing a function. This time we're going to graph the function f of x equals x plus 2 squared. This one's a little bit different in the sense that in our last function we had 2 binomials where we could easily see. And here I just see x plus 2 squared. What does that really mean? Oh, I know, we're squaring something. That just really means that I'm looking at the function f of x equals x plus 2 times x plus 2. Which means when it comes to the zeros of our function here, there's only 1. So we're going to have the 0 of the function. What value of x would make this function equal 0? Over there, yes. -2, good. Oh, that's so good. And because we only have 1, 0, our graph is actually be a little bit more unique here. Because we only have 1, 0 of this function, we know that this point here is our x-intercept. It's also going to be the vertex of our function, which means I can just make a table using my vertex, -2, 0. We can come up with some other values for this table, plot some points, and we'll be able to graph this. So if I plug in -1 into the function, what's -1 plus 2? 1. 1 squared is 1. -3, 1. We also plug in 0 because we know where we symmetrical across our axis of symmetry. I can match and pair these answers here, these values of y. What is 0 plus 2? It's 2, and 2 squared is 4. So 0, 4. We've got a happy little parabola here. Very good. Now we're going to look at one more piece of information for you, and then we'll be done for the day. Simple as that. Again, today's baseball day. I'm missing the fact that we can't watch baseball, like live baseball every day. But I do know I've got my Braves Tomahawk ready to go. We're sitting on Braves Boulevard, my National League team. Although it's not my only team, because of course, how can you not be a Rays fan living in Florida? And so I think I've got a special guest here. I do believe I see out in the distance a representative from the Rays. It's DJ Kitty, y'all! Let's go! Let's go! Here we go. It's time. Looking at a quadratic function again. Say you don't want to worry about factored form. You like the good old-fashioned standard form. I get it. There are ways we can convert our function, like this here, f of x equals 2x plus 3 times x minus 7, into standard form. One way, of course, is to use the FOIL method. Rejected. Fine. So again, FOIL, first times first, so 2x times x. We do our outside terms, so plus 2x times negative 7. Our inside terms, 3 times x. And our last terms, plus 3 times negative 7. Multiply it out, 2x times x, 2x squared, plus 2x times negative 7, negative 14x, plus 3 times x, 3x, plus we have negative 21. Combine our like terms, 2x squared minus 11x minus 21. That's, of course, one way for us to be able to multiply these together. Of course, the other way, well, not a little more akin to, is the...
Hey, what's up? I'm a superhero.
The super distributed property is one of my favorites because it combines the super distributed property along with my favorite, the old distributed property. Thank you, Mr. Carter. So, our super distributed property, we got to give 2x to that whole parenthesis, every piece of that set of parentheses there. So we have 2x times x minus 7 plus 3 times x minus 7. Now we've done a little bit of distributed property. We got to do a little more distributed property here because we've got to distribute the 2x to x and a negative 7. And how do we do that? By using the old distributed property. 2x times x is 2x squared. 2x times negative 7 is negative 14x. We do the same thing with giving 3 to everything in the parentheses using our old distributed property. Plus 3x and minus 21. Combine like terms. 2x squared minus 11x minus 21. Baseball day, complete success. I'm just saying. I mean, 3 days, 3 videos, clearing up on a Friday. This has been pretty good. I'm just saying, we're out here dropping bombs. I'll see y'all next week with some more videos. Let it ride.